Okay, we're on page 8 today, and we are going to finish up our discussion of linear functions, finish up our linear function review. Today, we're going to kind of take all the stuff that we've talked about so far and kind of put a bow on it. So we're going to see some graphs. We're going to interpret functions with a context. We're going to talk about points on a graph. We're going to write an equation. We're going to graph something from an equation. Everything that we've looked at so far kind of all tied together for today. To start, for our first example, I just want to look at a graph and talk about some of its key features. A lot of what we're going to see today will be discussing key features in a context. So what does this point mean in the context of the problem? So I just wanted to do a quick reminder of what some of those key features look like on the graph. The first one I'm asking you about is the y-intercept. We've talked about y-intercepts already, but since we're going to talk about all the or some of these other key features, I figured we'd throw y-intercepts in there too. So remember, y-intercepts are where our graph crosses the y-axis. So what's our y-intercept here? 5, right? That's where I touch the y-axis. So you could tell me 0, 5 or 5, depending on how the problem is worded. For this one, either would be fine. What's the x-intercept? That's where I cross the x-axis, and that happens at 4. So I could give that as an ordered pair, 4, 0, or I could just state the x-intercept as 4. Not too bad. We've talked about both of these already, particularly those y-intercepts. For number 3, we've got some function notation here. It says find f of 2 for the function represented by the graph. So remember, for function notation, we're used to seeing x inside those parentheses. Here, our x has been replaced by a 2. So I'm going to go to where x is 2. And then I'm going to follow that to a point on my graph. Now, this doesn't hit at a corner, so I'm going to have to approximate a little bit. But I'll say that f of 2 is approximately 2.5. We did a lot of function notation and evaluate functions based on a graph in first semester. We saw this throughout first semester, so a little review of that here as well. Questions for me so far? Okay. Number 4 should look familiar. A city parking garage charges a flat rate of $3 for parking 2 hours or less, and 50 cents per hour for each additional hour of parking. Write a function to model this scenario. We saw this yesterday. So y equals 50 cents for each additional hour plus the $3 for those first 2 hours. And then we're going to graph our function. So the function we've written is in slope-intercept form. That means I know the y-intercept is 3. And then we wrote this as a decimal because we were talking about money in the context of the problem. But when I'm graphing, it would actually be more helpful to have the fraction version of this number. So 1/2. 0.5 is 1/2. That tells me to go up 1, forward 2. And I'm going to continue using my slope to get me all the way across my graph. Up 1, forward 2. And then I can sketch in my graph if I'd like. Now, because this problem has a context, I do want to label the axes here. The y is my total cost, or my total charges. The x represents time, but I need to be careful with this one. It's not the total time that I've parked, because the first 2 hours are wrapped up in that $3 charge. So this is the additional time I've parked. And that's my additional parking time. Now, the graph I've given you only has the first quadrant available to you. Normally, when we've graphed, we've had all of our quadrants, but for this one, I've limited you to just this one, just the first quadrant. Okay, you don't have this or this or this available. Why did I not give you those other quadrants here? Why are we limited to the first quadrant? Why is that all that we need? I want you to think about the values you would have in those other quadrants. We're talking about money and time, right? Does it make sense to say I parked for -4 hours? Not so much. And is my total charge for parking somewhere going to be a negative amount of money? No, like they're going to pay me to park in their parking deck? No. So you won't park for negative time or owe negative money. All of our values here should be positive for X and for Y. C says, what is the y-intercept and what does it mean in the context of the problem? So what's our y-intercept here? Let's start with that. 3. Our y-intercept is 3. That's where I cross the y-axis. What does that 3 mean in the context of my problem? $3 for no additional parking time. Yeah. If you we'll say need no additional time, it will cost $3 to park. If you don't go beyond 2 hours, you won't have to pay any more than the $3. One thing that I've noticed that we struggle with a little bit when I ask you to tell me or interpret the meaning of something in the context of a problem. Usually we're pretty good about applying the label for whatever that value is. So for the y-intercept, usually we're pretty good about giving the y label, but then we don't give the full context. So a full answer here would not just be $3. $3 for what? What is costing me $3? Why is it $3? You have to rope in that X label too. So $3 when we have 0 additional hours of parking. Okay, you have to give the full context there. So for D, it says interpret one other point from your graph. I would like you please to pick any other point on your graph. We did the y-intercept together, so pick anything besides the y-intercept and interpret that point for me in the context of the problem. So pick any other point on our graph and tell me what it means in the context of our problem. Somebody tell me what point you picked. You picked the point 2, 4. 2, 4, that's on my graph. What does this point mean? There you go. 2 additional hours of parking will cost, you said a total of $4. Good. So you phrased this as 2 additional hours. We also could have phrased this as 4 total hours. If I took this 2 and added on the 2 that we get from the $3, either version of that is correct. So since this was our x-axis was labeled as additional parking, you kept the additional parking label. That's absolutely fine. If you had added on and said a total of 4 hours would cost a total of $4, that's also okay too. Questions for me here on page 8. Okay, let's go ahead and turn to page 9. Number 5 on page 9 has a big graph, but it's not, I don't think, a very difficult problem. Number 5 says, Harry noticed that the number of bubbles in his soda was decreasing. He observed its drink and recorded his observations in the graph below. So we have our graph here. It's labeled for us, minutes since first observation. So this is time, number of bubbles remaining. This is our number of bubbles. For A, it says, what is the y-intercept and what does it mean in the context of the problem? So what's the y-intercept from our graph? 12, right here, where I cross the y-axis, we're at 12. So our y-intercept is 12. And what does this mean for the problem? Yeah. Number of bubbles after 0 minutes, or we could also say number of bubbles when Harry first looked at the glass. Or there are a lot of different ways you could phrase this. There were 12 bubbles in the soda to start, or when Harry first looked, or at 0 minutes. The important thing here, what we just talked about a second ago, the important thing here is that I have both of my variables factored into my explanation. I talked about the number of bubbles and also when I had that number of bubbles. Both of those are important. That gives me the complete context. B says, what's the x-intercept? So what's our x-intercept? That's over here where I cross the x-axis at 24. And what is 24? What does that mean? There are no more bubbles after 24 minutes. There are 0 bubbles or no more bubbles after 24 minutes. "24 minutes is not enough. Okay, you have to tell me why is 24 minutes important? What is happening then? C says, what's the slope? So if we find 2 nice points on our graph, we can determine the slope. Let me scoot this down a little bit. So we go down 1 and forward 2. So my slope would be -1 over 2, since we go down 1 and forward 2. So the top of my slope equation here is my y. And remember, y represents how many bubbles we have. So the -1 here, my page keeps sliding. The -1 here represents that we are losing a bubble. Does that make sense? I go down a bubble. And then the 2 on the bottom represents the time it takes for that to happen. So it takes 2 minutes to lose a bubble. Does that make sense? Again, I'm applying both of the labels I have to the slope here. So we'll say the soda loses a bubble every 2 minutes. The soda loses a bubble every 2 minutes. Part D, find f of 6 and interpret it in the context of the problem. So we did a problem like this with number 1. F of 6 means our x value is 6. So I'm going to go to where x is 6, then I'm going to follow that to the graph. This is the point 6, 9. Okay. So f of 6 equals 9. And then what would this point 6, 9 mean in the context of my problem? After 6 minutes, there are 9 bubbles remaining. After 6 minutes, there are 9 bubbles remaining. Again, we have to give the complete context there. And then finally, for part D, it says find f of x equals 2 and interpret it in the context of the problem. This time, I don't know what x is. I do know that my y value is 2. So this will be very similar to D, but this time I know a y value. So I'm going to go to where y is 2, follow that to my graph, and I get this guy right here. I have the point 20, comma 2, right? X, comma y. So I know that f of 20 equals 2. What does that mean in the context of our problem? Yep, after 20 minutes, there are 2 bubbles, bubbles left. You could also say there are 2 bubbles left after 20 minutes. Either way to phrase that is fine, as long as you give me that complete context. What is the x? What's the thing happening with x here? What's the thing happening with our y value here? Questions for me on page 9? Okay. We have 2 more problems left for today on page 10. Since we've done a few together, I want you to try the problems on page 10. Okay, so you are working through number 6 and number 7 on page 10. I want you to give those a shot, and then we'll come together in a couple of minutes to talk about what you got. For number 6, we have a table here. It says as Delilah hiked a path on a mountain, she noticed that the temperature kept changing. The table below shows the elevations and temperatures she recorded. Write a linear model to describe the temperature based on the elevation. Now, I want you to notice here that our X values are not changing by 1 like they were in our tables at the end of our last lesson. Okay, we've got a 1,000 jump and then a 5,000 jump and a 2,000 jump, and the jumps are all different. So in order to find that rate of change here, I'm going to need to find the slope. So I'm just going to use the first 2 points. It doesn't matter which 2 points you pick, but I'm going to use the first 2 points. Remember, Y values on top, X values on bottom. So I would have 71.5 over 7,000 minus 76 over 6,000. I would use my calculator to simplify this. You're going to get your slope equal to a very small number on this one. So we would get negative 0.0045. So as I go to write my linear model, I've got negative 0.0045, and I'm going to have to write point slope for this one. I don't know the y-intercept or a starting like an initial amount as we talked about yesterday. So instead I'm going to use point slope form, and I'm just going to write it based on this first point. So x minus 6,000 plus 76 would be my linear model here. And now the next part of this question is what we did last time. Use your model to determine the temperature at an elevation of 10,000 feet. So I'm plugging in x equals 10,000. Again, I would do this on a calculator for the simplifying part. So 10,000 minus 6,000 in parentheses with that plus 76 at the end. And again, you can simplify this in your calculator. You end up with 58. So that would be 58 degrees Fahrenheit. That's our label for those temperatures. Part C asks me to find the y-intercept and interpret it in the context of the problem. We don't have the graph on this one. You could, I suppose, graph this in your calculator and find the y-intercept that way. But we found y-intercepts without having to graph before. We know that the y-intercept occurs when x equals 0. So I'm going to plug in 0 for x and use my calculator to simplify. So this would give me, if I take this into my calculator, 103. So in the context of my problem, that means that the temperature is 103 degrees. The temperature is 103 degrees Fahrenheit at an elevation of 0 feet. 0 feet would be 0 feet above sea level or at sea level. So you could have also phrased this as the temperature at sea level is 103 degrees Fahrenheit. Questions on number 6? The toughest part of this one was that you had to find the slope using slope formula, I think. And for number 7, we've got a graph here. It says Jada makes a graph to represent the weight of a jar when it contains different amounts of marbles. What does the y-intercept represent? It doesn't actually ask you to give the y-intercepts here. If it did, we would have to estimate. It looks like definitely it's less than 20, maybe a little more than halfway. So maybe our y-intercept is about 12, something like that. But it didn't actually ask me for that. It just wants to know, what does it represent? So what does this point represent in the context of our problem? The weight of the jar when it has 0 marbles. What's another way I could phrase that? There are 0 marbles in the jar and it weighs this much. That's just the weight of the jar, right? Okay. So you could certainly tell me that's the weight of the jar. Weight of the jar with no marbles or with 0 marbles. Or you could just tell me that's how much the jar weighs. Part B wants to know, what does our slope represent? And again, it doesn't actually ask us to find the slope. If it did, I could find two nice points and count between them. But it just wants to know, what does that represent? So the weight I can see is going up as my number of marbles is going up. So my slope, right, would be how much that weight changes every time I add a marble. So what do you think that number means? If the weight is changing every time I add a marble, what does this vertical change mean? It's what? It's positive, right? Why is it positive? It's going up, right? I've got this jar on a scale. I'm plunking marbles in there. The amount that the scale changes every time I plunk in a marble, what's that telling me? We said the weight of our jar is the y-intercept. That would be the weight of my marbles, okay? The weight of each marble. That's what my slope represents. So if I were to calculate it, that would tell me how much a marble weighs. C, interpret the point 30, 100. So that would be this point right here, 30, 100. So what does that mean? 30, 100. 30 what? 100 what? I just can't hear you. I'm sorry. 30 marbles. If I put 30 marbles in the jar, it weighs 100 grams. I'm actually going to phrase this a little differently. Sometimes the way that you word things can be a little awkward, even if it's technically correct. We'll say the jar weighs 100 grams when it contains 30 marbles. Or when the jar has 30 marbles, it weighs 100 grams. Either of those would work. Part D says, explain why the point 30, 60 is not on the line. So 30, 60 would be right here. Why is this point not on the line? I said 15 marbles. Oh, so you said when we've got a weight of 60 grams, that's actually 15 marbles. That would work. Okay. The other thing I could say is when I have 30 marbles, they weigh 100 grams. The big idea here is that 30 marbles does not weigh this amount. Does that make sense? However you phrased it, what I want to see is that this amount of marbles does not weigh this much. This weight is not represented by that amount of marbles. So I'm going to say 30 marbles in the jar does not weigh 60 grams. And if you included for me how many marbles would weigh 60 grams or the weight of the jar with 30 marbles in it, that is absolutely fine. Again, the big idea, the reason this point's not on the line is because that amount of marbles does not have that weight. Questions for me for today? Okay, I will remind you that you do have your linear functions delta maps to work on. At this point, we have covered all of our linear review. So next time we will start taking a look at quadratic functions. Okay, so at this point, you should also be able to complete all of those delta maps with these problems over your linear work.